Hello everyone, we're going to be going over section 5.4, which is on adding and subtracting polynomials. So we have 7 objectives of this section. Our first one, to identify terms and coefficients, combine like terms, know the vocabulary for polynomials, evaluate polynomials, add polynomials, subtract polynomials, and lastly, add and subtract polynomials with more than one variable. So quite a few objectives here that we're going to be going over, but we're going to make sure that we touch on each one. So objective 1, we want to identify terms and coefficients. So we want to recall that in an algebraic expression such as 4x to the power of 3 plus 6x squared plus 5x plus 8, we want to recognize that 4x to the third, 6x squared, 5x, and 8, these are all known as terms. It's something that we call them normally when we have discussion sections and things like that. So we know them as terms, and in the term 4x cubed, 4 is the coefficient of x. So whatever that number is that's being multiplied by our variable, we know those are our coefficients. So using this, we know that 6 would be the coefficient of x squared, 5 would be the coefficient of x, and 8 can be written as 8x to the power of 0, so 8 would also be the coefficient of x to the power of 0. So then we have a chart here with some terms and their coefficients. So we see that a constant would be its own coefficient, and then just any number that we see being multiplied by a variable would be our coefficient in that case. So we just have some examples here of some coefficients within their terms. So you can go ahead and pause the video if you'd like, if you want to look through those. Then objective 2, we want to combine like terms. So recall that like terms have exactly the same combination of variables with the same exponents on the variables. Only the coefficients may differ. So remember that our like terms are going to be the same variables and the same exponents. So this is going to be x and x, y squared and y squared, z to the power of 5 and z to the power of 5, things like that. Those are going to be our like terms. Their coefficients can differ, but that can be the only thing that differs. So some examples here of like terms, we would look at something like 19m cubed and 7m cubed, different coefficients, but we still have m cubed. Negative 37 times y to the power of 9 and 5y to the power of 9. Y to the power of 9 is in both, just different coefficients. And lastly, something like 2xy squared and negative 3xy squared. So even though we have different variables, we have an x and a y in this case, it is still just 1x and y squared. Then if we want to think about our unlike terms, something like 7x and 7y, same coefficient, but different variables, but they do have the same exponent. Z to the power of 4 and z, same variable, but different exponent, so they're unlike terms. And negative 4x squared y and 5xy squared. So in this case, we do have the same or similar variables, but our exponents are completely different. So using the distributive property, we can combine like terms by adding or subtracting their coefficients. So if we wanted to add our like terms here, if we wanted to add 19m to the power of 3 and 7 to m to the power of 3, we would just add 19 and 7 to get 26 m to the power of 3. Same would go for subtraction. Then objective 3, we want to know the vocabulary for polynomials. So a polynomial in X is a term or the sum of a finite number of terms of the form A. Sorry, one moment here. My laptop screen switched itself around. But all right here. So we're looking at form of A, x to the power of n for any real number A and any whole number n. So A would be our coefficient, x is our variable, and n is our exponent. So for example, the expression 16x to the power of 8 minus 7x to the power of 6 plus 5x to the power of 4 minus 3x to the power of 2 plus 4, these are all in descending powers of x. And this is a polynomial in x. So when we write them, they are going to be written in decreasing powers because the exponents on x decrease from left to right. So we always want to rearrange our polynomial If it is incorrect, we rearrange it. If not, we want to recognize that our polynomial needs to be written in decreasing orders. So our variable with the highest exponent is going to be first, and then your exponents will then go decreasing in order from left to right. So by contrast, the expression 2x to the power of 3 minus x squared plus 4x to the power of negative 1, which we could also write as 2x to the power of 3 minus x squared plus 4 over x. Since we know that x to the power of negative 1 is the same thing as saying 1 over x, and since it's times 4, it would be 4 over x. We would say that this is not a polynomial in x since the final term has a negative exponent. And so when we consider polynomials, we only really consider them with the whole number n. And let's highlight this to really keep this idea. Whole number n. And remember, your whole numbers are going to be 0 to infinity. So we're talking 0, 1, 2, 3, 4, 5, so on. So our whole numbers, not our integers. We don't count negatives. So the degree of a term is the sum of the exponents on the variables. I just realized I didn't spell that right at all. Variables. There we go. So that's what the degree of a term would be, the sum of the exponents on all variables. The degree of the polynomial is the greatest degree of any non-zero term of the polynomial. So some examples would be, if we looked at our chart here, degrees of terms and polynomials, something like a term or 3x to the power of 4, the highest degree is going to be 4, since we have that x to the power of 4. If we have something like 5x, our highest degree is 1. If we just have a constant like -7, then -7 can be expressed as -7 times x to the power of 0. So then our degree would be 0. Then if we have a mixture of variables, so let's say if we have x and y, something like 2x squared y, since y technically has an exponent of 1, we would add those exponents. So since x has an exponent of 2 and y has an exponent of 1, we'd add those to get 3. Then your degree of your polynomial is just going to be whatever the greatest degree of the non-zero term of the polynomial is going to be. So for example, if you have something like 3x to the power of 4 minus 5x squared plus 6, your highest degree in that case is going to be 4. Then also if you have a mixture of exponents, like how we saw before, if you have something like xy minus 5y squared plus 2x squared y, you still want to be adding those exponents of your terms in order to really determine the degree. So in this case, when we have x and y, the degree of that term is just going to be 2, since they both have an exponent of 1. 5y squared has a degree of 2 as well, but our 2x squared y, we would add 2 and 3 to get a degree of 3, and that would be the degree of our polynomial. So, just as an overview here, some polynomials have specific names. So a polynomial with just one term is called a monomial. And this would be something like 9m, -6y to the power of 5, or x squared. So we're just looking at one single term, no addition, no subtraction. A polynomial with two terms is called a binomial. So a binomial is going to be some term plus or minus another term. So something like -9x squared plus 9x to the power of 3, 8m squared plus 6m, or 3t minus 10. Then a polynomial with three terms is called a trinomial. So this is going to be adding or subtracting three terms. So this would be something like 9m to the power of 3 minus 4m to the power of 2 plus 6, or something like 1/2 y squared plus 3/4 y minus 1/3. So there are different names, so we will occasionally call them these names as well as we go through our section. All right. Then objective 4, we want to evaluate polynomials. So recall that evaluate just means to find its value. So we're really just solving, finding the value of an expression. So example 1, we want to find the value of the expression where x is equal to -2. And we have an expression here 3x to the power of 4 plus 5x to the power of 3 minus 4x minus 4. So if we just want to evaluate this polynomial, we're just going to plug x equals -2 in for all the places that we see x in our expression. So we are going to plug in -2 wherever we see x in our expression. So we're going to get 3 times -2 to the power of 4 plus 5 times -2 to the power of 3 minus 4 times -2 minus 4. And now we can go ahead and solve. -2 to the power of 4 is going to give us a positive 16. We have an even exponent with a negative base. So since our exponent is even, we'll have a positive number. So we're going to get 3 times 16. -2 to the power of 3 is going to give us -8. Since 3 is an odd exponent and we have a negative base, our answer will be negative. So we're going to have 5 times -8. 4 times -2 is going to also give us -8. And then we have a minus 4. So we can go ahead and simplify further. 3 times 16 is 48. 5 times -8 is -40. We have a minus -8, so that becomes plus 8 minus 4. And now we just want to combine our terms in order from left to right. So 48 plus -40 is going to give us 8. So now we have 8 plus 8 minus 4. 8 plus 8 is 16 minus 4, and that gives us 12. So the value of our expression when x is equal to -2 is going to be 12. So that would be how we would evaluate a polynomial for a certain value. Now, objective 5, we want to add polynomials. And to add two polynomials, we just want to combine like terms. So example 2, we want to find the sum of 6x cubed minus 4x squared plus 3 and -2x cubed plus 7x squared minus 5. So let's just identify our like terms. So our like terms in this case are going to be numbers with, let's begin with exponent of 3. So in this case, 6x to the power of 3 and -2x to the power of 3. Those are going to be like terms. Then if we go to x squared, -4x squared and 7x squared are like terms. And lastly, our constants, which are 3 and -5. So these are our like terms, and we want to combine our like terms. So if we want to find the sum, this means that we are taking 6x to the power of 3 minus 4x squared plus 3, and we are adding -2x cubed plus 7x squared minus 5. And we want to solve for this value. And we want to combine our like terms. So let's go ahead and do that. Let's group our like terms together so it makes it a little easier for us. So starting with x cubed, we'll have 6x cubed plus -2x cubed. Since we are adding a negative, we can just say minus. And remember, our operator here is addition, so we'll have addition in between our grouping. Let's actually move this down a little bit. So for x cubed, that's what we got. Now, for x squared, we have -4x squared plus 7x squared. So now we took our x squared terms and combined them. So we'll write this x squared, x cubed. And then lastly, we have our constants, 3 and 5. So we'll add 3 plus -5, which plus a negative we know is the same thing as subtracting. And we'll mark this as purple. And since they're constants, they're technically x to the power of 0. But now we've grouped together all of our like terms, and we can go ahead and use our operations to solve. So 6x cubed minus 2x cubed, this is going to give us 4x cubed plus -4x squared plus 7x squared is going to give us a 3x squared. And 3 minus 5 is going to give us -2. And there we have it. So when we want to add polynomials, we just identify our like terms. We can regroup them if you would like, and then we just go ahead and we add them together. All right, then objective 6, we want to subtract polynomials. So recall that x minus y can always be expressed as x plus -y. A similar method is going to be used for subtracting polynomials. So subtracting polynomials, to subtract two polynomials, you change the sign of each term in the subtrahend, our second polynomial, and add the result to the minuend, first polynomial. That is, add the opposite of each term of the second polynomial to the first polynomial. So let's go ahead and do an example. So we want to find the difference of 14y cubed minus 6y squared plus 2y minus 5 and the 2y cubed minus 7y squared minus 4y plus 6. And we want to find the difference. So our problem is going to look like this. We have 14y cubed minus 6y squared plus 2y minus 5, and we're subtracting our second polynomial. 2y cubed minus 7y squared minus 4y plus 6. But instead of subtracting, we're going to change this operation, and we are going to change to adding a negative. So instead, our first polynomial will stay the same. 14y cubed minus 6y squared plus 2y minus 5. And now instead we're going to say plus negative 2y cubed minus 7y squared minus 4y plus 6. Which we know that we can just distribute this negative, since our negative is like saying -1 times the inside of our parentheses. So we're going to distribute this negative, and then we would just go about adding our polynomials that we have left over. So now we get 14y cubed minus 6y squared plus 2y minus 5 plus -2y cubed plus 7y squared plus 4y minus 6. So this is our expression now that we're solving for. And we want to do it the same way as we did for adding our polynomials. So we're going to go ahead and we're going to just identify our like terms. Our like terms in this case will be 14y cubed and -2y cubed, -6y squared and 7y squared, 2y and 4y, And lastly, -5 and -6. So let's go ahead and regroup our equations here. Starting with our highest degree of polynomial, which is 4y cubed and -2y cubed, so, sorry, 14y cubed, plus -2y cubed, which we know adding a negative, it's the same thing as subtracting. Then we're going to add our next grouped like terms. Our next will be -6y squared plus 7y squared plus 2y plus 4y plus -5 plus -6. So 14y cubed minus 2y cubed is going to give us 12y cubed. -6y squared plus 7y squared is going to give us a y squared, or 1y squared. 2y plus 4y will give us 6y. And -5 plus -6 will give us -11. So really, subtracting and adding polynomials are extremely similar, but instead now when we subtract polynomials, we just want to make our second polynomial negative and add instead of subtract. So it's really just mostly adding polynomials with subtraction being a little bit different. All right, so objective 7, now we want to add and subtract polynomials with more than one variable. So it's really going to be the same because we're still just combining like terms. Just now we have more variables. Example 4, we want to solve the expression. We have 4x squared y plus 3xy minus -7xy squared, x squared y, sorry about that, plus xy plus 2x squared y minus 5xy. So we have our operations here, and we see we have subtraction. We have one subtraction, so we want to change to adding a negative. So we're going to rewrite our expression here. We're still going to have 4xy x squared y plus 3xy. And now we're going to add -7x squared y plus xy. And we're just applying that negative to our first expression here. Since we add or subtract in order from left to right, we can just focus on our subtraction between our first two terms. Just because there's a subtraction sign there doesn't mean that we have to subtract the rest of our expression in this case. So we can still just have plus 2x squared y minus 5xy there on the end. And now we want to change our expression again. So we're going to distribute our negative into our second polynomial. So our first polynomial stays the same. And now our second polynomial is going to be 7x squared y minus xy. And then we're still going to have plus 2x squared y minus 5xy. And now we can identify those like terms. So our like terms in this case are going to be 4x squared y and 7x squared y and 2x squared y. Then our other like terms will be 3xy, -xy, and -5xy. So we really only have two different sets of terms in this case. We have x squared y's and xy's. So we can go ahead and group our equations together. So starting with our x squared y, we'll take 4x squared y plus 7x squared y plus 2x squared y plus 3xy plus a negative xy plus a negative 5xy. So our first term here, 4x squared y plus 7x squared y plus 2x squared y is going to go ahead and give us 13x squared y. And 3xy plus negative xy will be 2xy plus negative 5xy will give us a minus 3xy. So really, even though there were more variables, it really wasn't any different than when we normally add or subtract polynomials. It's just that we have extra variables to be aware of. So all right, that finishes section 5.4, and we will continue on into section 5.5.